Hi, welcome to ACE Teachers Online, a series of online tutorials aimed to help students. My name is Sumedh, and today we'll be going through a question on HSC Physics ideas to implementation. So, today we're going to be going through a question from ideas to implementation. However, to fully grasp this question, you also need to understand concepts from the first HSC topic, space. So again, it is vital that you build upon the knowledge you'll learn in the first topic to help you in the future topics. So today we're going to be going through a question that incorporates elements from both ideas to implementation and space. So our question is, we have an electron horizontally entering electric plates that are 5 meters apart and have a voltage of 0.2 volts. These plates are set up to cause downward deviation of the electron. So what we need to do is any of these questions is firstly draw a diagram to help represent that information. So the first idea is that because the electron is undergoing a downward deviation, what this means is that the positive plate must be on the bottom and the negative plate must be on the top. Now, the main part of the question is it's asking what is the change in vertical displacement? In other words, from here to here, how far does the electron drop? Now this may seem like quite a hard question, but we now need to take a step back and just tell ourselves the only force acting in this situation is the electric force. It is acting in a downwards direction. This is very, very similar to something we'd encountered in space where we had projectile motion, which was defined as a downward force of gravity. So in other words, we can combine the equations of projectile motion with the electric force here, and that will tell us what is the change in displacement of the electron. So what we need to do is first find out what is this electric force. So F, any electric force is defined as F equals EQ. Now, E in electric plates is defined as V over D. So therefore, force equals voltage multiplied by charge divided by the distance. So now what we need to do is sub in all our values. Our distance is 5, our voltage is 0.2, our Q is the charge on an electron, which is in all your data sheets, which is minus 1.602 times 10 to the power minus 19. Now, all this negative sign is telling us is that the force is acting in the opposite direction to the electric field. In other words, the electron is moving towards the positive plate rather than in a general electric field where the force will be towards the negative plate. So now we have calculated the force. Our next step is to find the acceleration. So what we need to do is Newton's second law, F equals ma, and we know the mass of an electron, again, which is in your data sheet. So that there is the acceleration. So now, we have acceleration, our downwards acceleration. We also have our time, which is given in our question as 0.00001 seconds. So we have time, we have acceleration, we need to find displacement. So the equation we use is, so that there is the equation we use. Now, because the electron is entering horizontally, there is no ui, or there is no vertical component to its initial velocity. As a result, this is 0. So therefore, our change in vertical displacement is essentially this written up, which comes down to, now if we were to express this to 2 decimal places, this gives us, so therefore, our change in vertical displacement of the electron is 0.35 meters. This negative sign is telling us it is happening in the downwards direction. Thank you for watching our video. For the link to the previous video, please click here. For the next video, click here. And for the link to our website, click below. We hope to see you again.